All right, today we're going to be doing lesson 6.7, scatter plots and equations of lines. And I want you to go ahead and have a graph notebook out because you're definitely going to need a graphing calculator for most of this. And you will need graphing by hand for some of it too. So the graph notebook and the graphing calculator, both please. All right, we're going to look at a scenario first where you're going on a bicycle trip and you're biking a certain number of miles, and then the time is here. And what I want you to do is make a scatter plot to represent the data and then draw a trend line and write the equation for the trend line. And then we're going to go ahead and use the equation to predict how long it's going to take to go 32 miles on your bicycle. So the first thing that I want you to do is go ahead and graph this. And though I know you can make an argument that the miles depends on the time that you're biking, we're going to say in this scenario you have to go a certain number of miles and we want to know how long that takes you. So I'm going to put miles on my x-axis and time on my y-axis. I'm going to go ahead and make a good scale and write this all out, and I'm going to try to just pop up my graph afterwards. So you go ahead and pause and then see if we can come up with the same answers to save time. Okay, so you can see I still need to plot the 22, but I did the rest of the work fast without you. Okay, and so what I'm going to do here, I've made my scale, I have my line, my dots, and you can see that they look relatively close to linear, though not exactly linear. And one thing that I'm going to do is go ahead and show you how to make a trend line. So when we're making a trend line, what we want to do is make sure that the line follows the slope of the data relatively. And usually we want it to include about the same number of points above and below the line. So that will make it match out for us. So if I'm trying to draw a line, I'm just going to guess a little bit right now. So I'm going to play with this line a little bit. Okay, right now it doesn't look all that great because it's above most of the points. That wouldn't be that great. That would be below most of the points, not that great. And I want it to be kind of in between them, and I want the slope to be right too. So I don't want it to be like really extra steep or really narrow or flat. So I want it to be kind of as close to the middle as I can, following the right slope, trying to give the right progression. To me, it looks pretty close to this. That might be a pretty good trend line. Okay, so what I'm going to look at here is trying to figure out an equation for my trend line. So when I'm trying to figure out an equation, I first want to come up with a couple good points that I can use to help me to figure out a slope and a y-intercept and that kind of thing. So to me, it looks like right here might be a good one because it's right on a point at 524, even though my real dot in my graph is 527, but on my line it looks like it's right about 524. And then this one looks pretty good to me again because again it's right on a line. So that's the point 1360. So what I'm going to do is I'm going to use these 2 points to make an equation for my line by finding out the slope and the y-intercept. And in this case, from 24 to 60, it rises 36, and from 5 to 13, it runs 8. So if I do 36 divided by 8, it looks like my slope is about 4.5. So that's my slope. And then when I'm trying to figure out the rest of my equation, I might use point slope form because that's easy to use to write an equation. So I'm going to go ahead and use that point 524. So I'm going to say y minus 24 equals 4.5 times x minus 5. And I'll go ahead and change that into slope-intercept form just because I think that will be a little bit easier. So if I'm going to distribute 4.5 to x minus 5, then I can go ahead and just say that's 4.5x minus 22.5, and that equals y minus 24. And I'm going to add 24 to both sides. And I get that y equals 4.5x plus 1.5. So this seems to be a pretty good equation for my trend line. So here it looks like I'm going about 4.5 miles per hour, and I started at 1.5 miles. Or after 1.5 minutes of doing nothing. And I lied, I'm going 4.5 minutes per mile. Okay, so here, the next question, when I use that equation, it's important to know that x is miles, and y is minutes in this case. And I have been asked in my previous problem to predict how long it's going to take to go 32 miles on the bicycle. So in my scenario here, 32 miles, that's going to be substituting in for x. So I'm going to do 4.5 times 32 plus 1.5. So 4.5 times 32 plus 1.5, I'm going to have to do that on my calculator. I don't want to. I get 145.5. So that means I think it's going to take about 145.5 minutes to go 32 miles. Okay? So obviously you may have done an equation that's a little bit different depending on how close your trend line is to the actual trend line. And you're going to see, I'm going to compare mine to the book. I bet it's not going to be that close. But it should have about the same approximation. And your slope should be similar and your y-intercept should be similar. Here's the book. They think it's going to take about 32 miles for 162 minutes. So based on mine, I thought 145.5. Mine was lower than what they have. It's not super far off. Okay. We are going to look at drawing a line of best fit. Going by hand can be pretty tedious, making a trend line and coming up with the equation and all that. And though you will need to know how to do it by hand, I also want to show you how you can do it on a calculator to be more precise, since like my prediction was, you know, I'm a math teacher and I was still a good bit off. In the line of best fit, we're going to get a little bit more precise by using our graphing calculator. So we are going to know a line of best fit is the trend line that shows the relationship between two sets of data the most accurately. And we are not going to do this by hand. We are going to use a calculator if we're going to get really accurate. Trend line would be just semi-accurate. There's this thing called the correlation coefficient, and it's R. It tells how closely the equation models the data. If you have a correlation coefficient that's really close to 1 or a -1, that means it's very close to being perfectly a straight line. So almost exactly linear. If it is exactly 1 or -1, it's in a perfectly straight line. If it's really close to linear, or really close to 0, it's not even close at all to being linear. Your model's not a good prediction. So this can kind of let you know. Here would be a pretty strong negative correlation that looks relatively close to a line it's going down. It would be pretty close to -1, you know, maybe at -0.9 something. Okay, this next graph in the middle, that's just all scattered apart. That's going to be close to 0. That doesn't have much of a linear relationship. This last one, it's a positive, so it's going to be close to a +1, and it's really quite straight, so it's probably in the 0.9 range again. So we are going to look at some data, and I'm going to show you how to use a graphing calculator to solve this. So you're going to use a graphing calculator to find the equation of the line of best fit for the data below. And then I want you to figure out what the correlation coefficient is too. Okay, I highly recommend you get out your graphing calculator and try this with me, because it's really hard to remember something like this unless you've actually practiced in doing it. So what we're looking at is the U.S. crime rate here per 100,000 inhabitants. And you can kind of see that the U.S. is kind of proud of this, because in general it looks like the trend is that the crime rate is going down. And what I'm going to ask you to do is plug in this data into your graphing calculator. So here's a couple things to remember. Stat edit and stat calc/linear regression. So I'm going to look at my graphing calculator and I'll show it to you. Okay, and the first thing I'm going to do is go ahead and click stat. And right there it says edit. So what you're going to notice is you have these two lists. If you have anything in your list already, you can go to the top and hit clear like I'm doing. And that will clear out the list for you. And what we're going to do is type in the data that we have. I'm going to clear that list again. In list 1, you want your X values. In list 2, you want your Y values. A tip is that sometimes when you're doing problems with years, it's good to like call the first year 0 instead of like 1995, because sometimes you can get a little better picture. So instead of 1995, 96, 97, 98, 99, in list 1, I'm going to put 0, 1, 2, 3, and 4. So you just simply type them in and hit enter in between. But the important thing is remembering what those meant, okay? And then in the next one, list 2, I'm going to type in my values. So it was 5,275.9, and you should be going ahead and trying to do this on your graphing calculator. And then 5,086.6, and then 4,930, and then 4,619.3, and then finally 4,266.8. Okay, so I have entered all the things into my calculator. I have all the data for the years, which I'm calling 0, 1, 2, 3, and 4, and then my crimes per 100,000 people. Okay, so remember I said, remember stat, edit. That's how you get there. When we want to come up with a line, we're going to remember stat, calc. So you're going to arrow over until you see calc. And then one thing you're going to notice is right here on 4, it says linear regression, ax plus b. That is where you're going to go to find your equation of your line. So linear regression, ax plus b, hit enter. And that's going to come up. Go ahead and hit enter again. And lo and behold, here is all this stuff, y equals ax plus b. So it says a equals negative 248.55, and it says b equals 5,332.82, and then remember when I said correlation coefficient? So that correlation coefficient, r right here, it's negative 0.98549, etc. That looks like it's very close to being a straight line. Very close to being a straight line because that number is very close to -1, and it should be slanting down. What I'm going to show you how to do next is how to see this on your graphing calculator. So if I want to look at my stats, I'm going to go up here where it says stat plot above F1, second stat plot, and I'm going to turn plot 1, instead of it where it says off, I want to change that to being on. So plot 1, I want to turn that, I'll hit enter, and I want to make it on instead of off. And I just want the type where it's just dots, okay? And I can see it's list 1, list 2, and that looks good. So now if I want to see it, I'm going to go zoom, and 9 says, if you go all the way down to 9, you can see where it says zoom stat. And that's what I'm going to pick. Oops, I'm going way too far, but I'm just going to hit the button 9 so it works. You can see right here I've got my points on my graph. And if I want to actually see how the line compares to that, I can type in my equation. There's other shortcuts to do, but I always forget them. So I'm going to actually type it in. Y equals negative 248.55x plus 5,332.82. And if I hit graph, I should hopefully see the line. And you can see it's quite close to the points. It looks pretty good. It's a good fit of that. Okay, let's go back and see what this means in terms of the problem. Okay, so it says the correlation coefficient. That was my R value. So R happened to be about negative 0.98549, and my equation was y equals negative 248.55x plus 5,332.82. Okay. And so that looks pretty good. Okay, the last very most important question here. Some of you are going to say, well, R didn't show up on my graphing calculator. It didn't show up for me. So I'm going to show you how to do that. What you do is you go to your catalog, and there's a button that says Diagnostic On. That's what you're going to pick. So I'll show you how to do that really quick, and then that hopefully will work for everybody, and you'll get your correlation coefficient R to show up. So in my graphing calculator again, your catalog, it's found right above 0, so you can hit second 0. And if I want to go to the D's, I can just hit the button that has a D above it, which is x to the negative 1 for me. And then I'm going to scroll down to where it says Diagnostic On, and yours is probably a little quicker than mine, but there's Diagnostic On right there. If you hit enter there, then hopefully it's going to say done, and when you actually